All right, so now let's talk about the four fundamental forces that control the universe. And I introduced the concept by telling you that for every particle in the universe, so for quarks, there is a quark field that goes with it. For electrons, there's an electron field that goes with it. For magnetism, there is the magnetic field that goes with it. And then when one of these fields vibrates, it will create a particle. And so, for example, when you wiggle the gravitational field, you get a particle called the graviton. When you wiggle the electromagnetic field, you get a particle called the photon. So these were particles that are created when a field wiggles. Now, what do you need to know for the exam? You ought to be able to give me the name of each of the four fundamental forces. You should be able to tell me what does it do in the universe, and you should know what is the particle that carries that force. So 3 pieces of information for each of the four fundamental forces. Okay, so let's first look at gravity. So the gravitational force, it's the thing that holds the universe together. Anything that is really, really big, it's the job of gravity to hold it together. So it's going to hold superclusters together, clusters of galaxies together, stars together, planets together. So anything that's really big, it's the job of gravity to hold it together. Okay, what is the particle that creates gravity? So it's going to be called the graviton. Make sure and know that word for the exam. Okay, this just shows you what is an exchange particle. So the graviton is the exchange particle that causes gravity. Okay, then you've got electromagnetism. So it's the atomic glue. It's the thing that's holding you together. So you are composed of atoms. The atoms have a positive nucleus and then has negative electrons, and opposites attract. So it's the job of electromagnetism to hold atoms together. And then you should know that the carrier of the electromagnetic force is going to be the photon. Then you've got the strong nuclear force, which is responsible for holding 2 things. It will hold protons and neutrons together to make a nucleus. But it also holds the quarks together that are inside the protons and the neutrons. And then the particle that is responsible for the strong nuclear force is going to be called the gluon. Okay, then you've got the weak nuclear force, and so you can think of it as doing 2 things. So that it can change a neutron into a proton, and then in doing so, it also emits an electron, and it emits a neutrino. Sorry about that. So plus a neutrino that has an electron on it. Okay, but another way of thinking about it is that it can change, like for example, a up quark into a down quark. So it can change a quark. And when it changes the quark, it also gives off the same 2 particles. So it's also going to give off a electron, and then it's also going to give off a neutrino that goes with the electron. So this is the reason why you need to have both quarks and leptons when you're describing what matter is. So the quarks make up matter, but the leptons, the neutrinos and the electrons, are necessary in order to change one kind of quark into another kind of quark. And then the particle that carries the weak nuclear force is going to be called a weak boson. And it's those W particles there. Okay, got to know what the Higgs boson does. So the Higgs boson doesn't cause a force, but the Higgs boson gives mass to particles, and then mass in turn does cause a force. It causes the force of gravity. So the Higgs boson is going to be a fundamental particle that gives mass to other particles. So that's all that you need to know. Don't worry about the Higgs field. Don't worry about the wiggles in the Higgs field. But if you enjoy this kind of stuff, and who doesn't, you can watch this little video on it. So then, here's a chart that shows everything we've been talking about. So you can see it's got the leptons, and then it's got the quarks, and then underneath it, it has the different kinds of exchange partners or particles that cause the different forces of nature. All right, let's take a break. When we come back, we will talk about unification of the fundamental particles and unification of the fundamental forces.